Okay, my name is Moritz Dechamps. I'm a doctoral student at Markus Meier's lab in Munich, in LMU, Ludwig Maximilian's University. And in this talk, I would like to talk with you about the relationship of mind and matter, whether one can influence the other, and why such an influence often works only the first time and declines later. And finally, I will propose new methods that might allow to consistently test a mental influence on the physical world. And I'm going to show you how we applied them on smoking participants. So if you're a regular smoker, be extra careful. Okay, before we jump to the minds of smokers and non-smokers, I'd like to show you where we come from regarding the relationship between mind and matter. We've heard something about that yesterday, I guess, but I'm still going to talk about it a little bit because I think the theory is quite important. Perhaps most familiar to our day-to-day experiences is the notion of mind and matter as two distinct entities. That's the Cartesian dualism, as famously propagated by René Descartes. And this approach introduces a fundamental split between all things physical, that's the blue circles, and all things mental, that's the red circles. And still, both these worlds seem to interact with one another. So thoughts become actions and experiences become impressions. Cartesian dualists would explain this correlation through a bidirectional causational interaction, but both these causations are very hard to explain as regards content and logic, and indeed they are known as the hard problem of consciousness. That's the question how physical events elicit phenomenal experiences, and the hard problem of free will, the question how mental content is translated into physical correlates. Consequently, other forms of thought have replaced the Cartesian dualism. Mainstream science nowadays seem to favor a materialistic and therefore essentially monistic worldview. Physicalism states that all aspects to reality, and this includes mental states, can be explained by specific physical configurations. And this would mean that every conscious state can be represented one-to-one by matching neural correlates, for example. And this is something that could not be shown so far, and in fact there's evidence pointing in the other direction. The mind and matter in this view, moreover, is often regarded as a mere byproduct. So it's an epiphenomenon and therefore has no say at all, which is kind of sad. I would like to introduce you a different model of mind and matter, and that's called the dual aspect monism. We already had something about that yesterday as well. In this view, mind and matter are seen as two distinctions of one underlying substance of which they emerge. And this substance is sometimes called unus mundus, depending on the theory, or implicate order, or since it's not directly accessible and therefore pre-real, I'll call it pre-reality. Mind and matter are not connected directly, but they are parallel as a consequence of their joint origin. They are structurally correlated. The transition from the holistic pre-reality to the distinctive mental and material representation happens in a so-called epistemic split. And Jung and Pauli, one of the authors that thought about one of those models, they assumed a second kind of correlation that is bidirectional in nature. And this means that through unconscious processes, the pre-reality could be affected by mental activity. And this in turn could lead, after the epistemic split, to meaningfully related correlations between conscious experience and the materialization of corresponding physical states. This is called induced correlations, and the corresponding phenomena are labeled synchronistic events, and they're supposed to be evasive, occasional, and not easily, if all, reproducible. Even though this concept addresses the logical difficulties of some of the other theories, a lot of questions stay unanswered. But then came the advent of quantum theory. So many principles are addressed in quantum theory. For example, the wave and the particle nature are complementary, but they still belong together. There is a transition from a not directly experienceable and holistic quantum state to a classical one. It's called measurement here. And interestingly, dependent on the favored interpretation of quantum mechanics, we heard something about that yesterday during dinner, measurement can be understood as a conscious realization of a quantum state. Or maybe, yeah. So let's go back to the dual aspect monism theory. And let's take another look at it. We can now define the relation between the mental and the physical aspects as complementary related. So they are mutually exclusive, but still belong together. The epistemic split, there was the transition point, is called measurement on the physical side, and we know it goes hand in hand with the moment of conscious realization. Finally, induced correlations can be understood as a psychogenic biasing of quantum probabilities. And this biasing of a probabilistic system, that is something that we know of, and that has a long-standing parapsychological tradition, and it's called micro-psychokinesis, of course. So most of you will know what it is. I still brought a definition from two of the members with me. So there's pretty convincing meta-analytical evidence for micro-PK, as you can see at from the data from the Bösch, Steinkamp, Boller meta-analysis, but there's still problems regarding micro-PK, and that's mainly its reproducibility. So specific results often cannot be reproduced. This will happen on a subject, like on an individual subject level. This will happen also across participants or even across a set of studies. We already heard something about the replication of the pair study. I'm not going into the detail again. But this happened also at the study I'm going to talk about in the following slides. And there's even indication that this decline happens over a whole meta-analysis. This can be, for example, seen at this plot where all the studies from the meta-analysis are shown in a chronological order. And you can see that the effect size gradually decreases. So this leads to the question whether micro-PK or psi effects are not reproducible in principle. And there's some arguments for this idea. I already told you about Pauli and Jung's notion that those induced correlations cannot be reproduced. You can also look at quantum mechanics no-signal theorem that states that entanglement cannot be used to transmit signals, and the same could be applied to generalized entanglement correlations. That means not between quantum states, but between quantum and mental states, for example. And that's the no transmission axiom. We've heard about that earlier as well. The source for this decline could, in congruence with the dual aspect framework of mind and matter, lie in either one of those areas. So there could be a physical explanation, there could be a psychological explanation. One physical explanation is offered by the model of pragmatic information that says when an effect is, like a micro-PK effect is exerted, the system's pragmatic information is comprised of novel and autonomous behavior. And when this behavior is repeated and observed so many times that it can be expected, the information shifts again towards confirmation and reliability, and this will ensure that the novel effect disappears once more. There could be a physical correlate to this interplay based on the second law of thermodynamics, which states that entropy will always increase in a closed system. And a purely random process possesses more entropy than a biased one. And this means that in the case of a micro-PK effect, information is created where there used to be none. And this is a violation of the second law. For this reason, this state cannot persist indefinitely And you could imagine that an entropy increasing counter effect could set in at some point, equalizing the original effect and ensuring that the information is lost again. Interestingly, this interplay of effect and counter effect should lead to an oscillative pattern of up and down movement in the data. The decline could be psychological as well. We think that micro-PK creates a correlation between implicit and meaningful mental states and corresponding physical states. So there must be a pretty strong implicit belief in the subject for micro-PK to happen. For example, I am a lucky child, I am lacking nicotine. This will become relevant later. And Jules Eisenbut argued that there might be a different fundamental belief that all people hold, and that is the desire to live in an orderly world that has rules everybody can rely on and understand. And if these rules are skewed too much through a directional micro-PK effect, this belief might take over and we unconsciously use our micro-PK ability to counter the effect. So it could be something that we are doing unconsciously by ourselves. Yeah, regardless of the source for the decline, it happens so regular that we need to ask the question if mind-matter interactions are not testable in principle, or if they might be testable if we find some sort of oscillative pattern. And finally, let's go to the data, to some empirical data, and smokers will come into play here. I would like to show you how we empirically address this question. We conducted a simple micro-PK experiment. We tested participants with a specific mental attitude towards cigarettes, that's regular smokers, and we compared them to non-smokers. We hypothesized that the mental state of smokers, that is lack of cigarettes, triggers an induced correlation leading to a corresponding physical event that is the number of stimuli changing the number of stimuli that address this need. To test this hypothesis, we asked 500 smoking and 385 non-smoking subjects to attentively observe a series of 400 images, and the images were produced depending on the output of an RNG, and whether the RNG produced a 0 or a 1, the participants saw a cigarette picture or a neutral picture. We did 3 studies that worked this way. In the first study, smokers showed a highly significant avoidance of cigarette pictures, and no such deviation can be found with the non-smokers. And then naturally, we decided to replicate the finding, but in study 2 and later in study 3, we could not replicate the finding. Still, overall, it's a significant deviation from randomness within the smokers, but not non-smokers. Before going into details, I would like to say a few words about the statistical approach we used, and that's the Bayesian approach. Bayesian statistic works by updating beliefs given new data and by pitting the likelihoods of the data to be produced by the concurring hypotheses against each other. Interestingly, this allows for sequential testing. So usually you keep on testing until a pre-specified stopping criterion is met. The evidence is measured with the base factor. That's the relationship of the probabilities. So a base factor of 1 means both alternatives are equally likely. A base factor of 10 means one hypothesis is 10 times as likely as the other, and that's usually considered strong evidence. Okay, and this is where it gets interesting. I'm going to show you the sequential Bayesian analyses of the smokers and the non-smokers. It looks like this. So as you can see, there are vastly different graphs of the smokers and the non-smokers. The smokers are the red line, the non-smokers are the blue line, and additionally we created 10,000 simulated data sets. That's all the gray lines, and because that's so many data sets, there's a small yellow area at the bottom. That's where 95% of all the simulations lie inside, and the bottom gray line is the median of the simulations. So this is what a typical simulation would look like. It starts at 1 and then goes into the bottom in the direction of the null hypothesis. Okay. And you can see that the smokers behave completely differently, right? They go up in the direction of the alternative hypothesis up until a base factor of over 400. That means it's 400 times as likely to have a non-random behavior. And then they drop again really, really quick. And they stop at a base factor of 1, which basically means there's no evidence in either direction. Okay, so what to make of that? Apparently, there's a decline at work here. Even though there's a really strong initial effect present, the evidence is later neutralized in the end. And still, the development of the curves are very different. And that's why we decided to try to find some measures on a post hoc basis to discriminate those different developments of evidence. We came up with 3 methods. The first one is we looked not at the latest, like at the last base factor, like it's usually done, but we are looking if there's what's the highest reached base factor over the whole data collection. And we can see in the comparison to our randomly collected data, again, that's 10,000 just purely random data sets, that a base factor of 421 can only be expected by chance with a probability of about 0.21%. So it's very unlikely. Next, we decided to further examine the whole development of the base factor curve. That means we compared its strength of evidence to the hypotheses. So to do so, we calculated the curve's energy, and we subtracted the areas below the lines, below the baseline, that's the red areas, from those above it, the green areas. So the energy of the smoker's data is, as usual, as the highest point. It's surpassed by only 0.15% of simulations. Finally, we wanted to look for an oscillative element in the evidence development, and to do so, we applied a Fourier transformation to the curve. This is an analysis that converts a time-dependent function to a representation of its composited frequencies. So you can see an example here. The resulting transform shows the amplitudes of all frequencies comprising the original sequence. Those are the fast Fourier transforms of the smokers on top and the non-smokers on the bottom. Again, there's 10,000 simulations each. And on those are gray lines, and the yellow areas is where 95% of the simulations lie, and the bright yellow area is 99% of the simulations. Again, the subsamples differ tremendously. Smokers show a very high amplitude. That means a very pronounced oscillative element at virtually every frequency. In fact, when compared to simulations, 98% of all frequencies have a higher amplitude than 99% of the simulations, and all of the amplitudes have a higher, all of the frequencies have a higher amplitude than 95% of the simulations. That means they're all above the yellow areas at all times. This applies to not a single frequency of the non-smoking subsample. Okay, so what can we conclude from this interesting set of experiments? Firstly, the randomness postulate of quantum mechanics generally upholds if there's a meaningful connection between mental and physical states. However, induced correlations could be produced by a biasing of quantum probability. This only works to a certain extent, though. As countless examples have shown, micro-PK and other psi effects regularly decline and therefore elude a detection based on reproducing results. The reasons for that might lie in the physical realm, the anti-axiom, the pragmatic information, or the reduced entropy of a biased system, or of a psychological nature, and that there persists an unconscious resistance to strong psi effects. Since mind and matter can be understood as two aspects of the same thing, one might even be congruent to the other. Finally, there still might be a way to test the occurrence of an effect despite its decline. We shouldn't only consider end results, but we should investigate the development of evidence for an effect over time. We propose the methods presented here, comparing the highest reached base factor, the base factor curve's energy, and its Fourier transform to randomly generated simulation data. And I would like to appeal to all my fellow Psi researchers to try out these methods with their data. Thank you.
Okay.